Okay, now we're going to discuss about yield. Yield is the amount of product that you gain from one experiment or one reaction. So there are three terms that you need to be familiar. The first one is the theoretical yield. Okay, so what is theoretical yield? That is the yield that you get from your stoichiometric calculation. So just like we discussed stoichiometry before, so we actually can predict how much we get from one reaction by knowing the chemical equation as well as the amount of reactant used. So we convert the mass of reactant into mole, and then we do the mole ratio from reactant to product. So there we know how much product that we can produce theoretically. Okay, now we also need to know what is actual yield. Actual yield is actually the real amount that you get from the experiment. Okay, so the real amount usually lesser than theoretical yield. Well, because usually in lab we do many simple mistakes. So usually the amount is slightly less than the theoretical yield. Okay, so what is percent yield? Percent yield is actually the simple as actual yield divided by theoretical yield and multiply by 100. Okay, so let's so kita tulis kat sini actual divided by theory multiply by 100. So this is what we're going to do. Okay, so the question said silica carbide reacting sand with powdered carbon at high temperature. What is the percent yield if 51.4 kg of silica carbide is recovered? So what does this mean? Meaning that from this reaction, it produced 51.4 kg of silica carbide. So this is the yield. What yield? This is actual. Okay, so this is actual yield because it is given. Okay, so this is given from processing 100 kg of sand. So this one is 100 kg. So you see, you have the mass of reactant, then you can find the mole ratio from reactant to product. And then we multiply by the molar mass. Okay, so always remember when we want to calculate by mole, meaning that you have to convert all mass into grams because our calculation in mole, okay, molar mass is in grams. Okay, so 100 kg equivalent to 100,000 grams of silica oxide. We start from there. Okay, so the first one is I want to convert our mass into mole. Okay, convert mass into mole, meaning that we need to divide by the molar mass. Okay, so what is the molar mass? Molar mass for silica oxide, in 1 mole of silica dioxide, there are 60.08 grams, okay, of silica dioxide. Okay, and then when we get the mole, we actually want to do the mole ratio. 1 mole of silica oxide is equivalent to 1 mole of silica carbide. Okay, up until this point, we actually know already the mole of silica carbide. But that's not what we want to know. We want to know the mass. Okay, so we need to calculate in 1 mole of silica carbide, it's actually correspond to 40.11 gram of silica carbide. But again, we want the answer to be in kg because our actual yield is in kg. So gram, meaning that 1000 gram equivalents to 1 kg. Okay, so we actually, you see, I can cancel out gram of silica carbide. I can cancel out gram juga. Mole of silica dioxide. Okay, sorry, tadi silica dioxide. So ini pun cancel out mole of silica dioxide. Silica carbide, mole of silica carbide I can cancel out. Gram of silica carbide, this also 1 gram, 1000 sorry. 1000 gram of silica carbide. Okay. So when I calculate everything, I'm going to get, it's actually how you calculate is actually 100,000 times by 40 divide by 60 divide by 1,000. Okay, as simple as that. So you're going to get 66.76 kg of silica carbide. So you see, it is bigger than our theoretical. Theoretical is bigger than actual. So soalan minta percent yield. So we just calculate, right? 51.4 divided by 66.76 times 100 equals to 1.4 bahagi 66.76. So you got about 76.992%. Banyak tu. Okay. So madam boleh tak kalau saya nak jadikan dia nombor bulat ataupun tu, make sure it is a 3 significant figures. So 77.0%. Okay.